All right, folks. One of the things we need to talk about before the CBA, because I'm afraid they're going to put some of this on there, is linear transformations, which we will discuss at length when we do lines after Christmas. However, I don't want you to tell me that I didn't teach you this before the CBA. All right, now a lot of this is probably going to be familiar because you guys did lines a lot last year, right? One thing you should be ready or familiar with is y equals mx plus b. That's one way. Trash can, please. That is main, yes. That's one way to write the equation of a line. All right, that's called the slope-intercept form of a line. Y'all remember that? So what number is the slope? Or what variable represents the slope here? M. The slope is represented by M. Where do you find the slope? In front of x. If it's written in this form, you look in front of the x and there's the slope. What else is part of this formula here? B. What does B represent? The y-intercept. That's represented by B. It's added or subtracted at the end. And we're going to talk about what happens to a line when you start messing with its slope and messing with its y-intercept. It transforms the line. This is called linear transformations. All right, slope. Let's define slope. Slope, yes, it's rise over run. We can figure out how to find slope, but for today's purposes, I want you to know how slope affects a line. Slope is just a number. Please don't tell me slope is x. Slope is usually found in front of x, but slope is not x. It's a number. And what that number does for us, it describes the direction. That means either the line's going up or down. Oops. It describes the direction, which means either up or down, and the steepness of the line. Y'all know what steep means, right? Okay, it can be steep going up or steep going down. That means when it rises or falls very quickly, like a steep mountain. It's more on the flat side if it's not rising very quickly, like a gradual incline, like a hill or just. Okay, and if it's completely flat, then its slope is actually 0. And what is y-intercept? Let me scoot this down so I can. Y-intercept, which is the B number. What does that tell us about the line? Exactly. It's where it intersects or crosses or touches the y-axis. And as we change the y-intercept, that will change the appearance of your graph of the line as well. All right, are we good with that? So you're familiar with slope, you're familiar with y-intercept, you're familiar with graphing lines. Or you should be. Trust me, we will know how to do lines inside and out after Christmas. Tomorrow we are taking a quiz over domain and range. All right, I'm changing screens. Can I change screens? While you're finishing up these notes before I change screens, I want you to realize this is not the only way to write the equation of a line. It's a nice way to write it because we can see the slope and see the y-intercept right away. But we are going to learn all different ways to write equations of lines. This is called the slope-intercept form. And it is very useful. That's probably the one we use the most. That's the slope-intercept form. It's called slope-intercept because I can easily see the slope and the y-intercept. Okay, now here's where you got to pay real close attention. I know this lesson is not very exciting. I don't like teaching it, but I'm afraid they're going to put it on the CBA, and I want you to be ready for it. All types of function have what's called a parent function. We're going to look at lines, parabolas, exponential functions, all kinds of functions. Today we're focusing on linear functions. And basically the parent function is the simplest type of parabola or line or exponential equation that you could write. For a line, the parent is y equals x. That is the parent function for all lines, y equals x. And yes, you have to know that. Yes, you should be writing this down. What's the slope of the parent function for lines? I said, what's the slope? And I'm hearing people tell me x and y equals 0. So what is the slope for this line? This is a line right here. The slope is not 0. Yes, it's 1. The slope of the parent function for lines is 1. What's the number in front of x? A 1. There's an invisible 1 there. What's the y-intercept for the parent function here? 0. Okay. B is the number added or subtracted at the end. Is there a number being added at the end? What can I put there without affecting the value at all? I could put a plus 0. This is the parent, not the baby. Alright, y equals x. You gotta know, folks, stop. You gotta know that this is the parent function, and you should be able to tell me what the slope and the y-intercept are for the parent function. Slope is 1, y-intercept is 0. This is the easiest line you could possibly draw. Because whatever I put in for x, I get right back for y. For example, if I put a 1 in for x, what do I get back for y? A 1. If I put a 0 for x, what do I get back? If I put a negative 1, what do I get back? Okay, this is not considered steep or flat. It's right through the first and third quadrant. It passes through the origin. That's the simplest line we could write, y equals x. Now, as we start changing and messing with the slope, and changing and messing with the y-intercept, then this picture is going to change. Y-intercept changes. Let's do that first, because that's the easiest. Let's say I wanted to take this parent function, y equals x, and I wanted to change its y-intercept. What would change then? The 0 would not be a 0 anymore. So give me an example of a line that has the same slope as the parent, but a different y-intercept. Y equals what? Plus y equals 1x plus 5. Do you agree that's a y-intercept change? Yes, it is. What was our y-intercept on the parent? 0. What's our y-intercept now? 5. That's a y-intercept change. Guess what's going to happen to the whole line? How, though, specifically? It's going to shift up 5 spaces. So my y-intercept will not be at 0 anymore. It'll be at 5. What doesn't change? The slope did not change. Now, I know my drawing's not perfect, but imagine that these are perfect parallel lines. When you change the y-intercept but don't change the slope, you create parallel lines. All the y-intercept does is moves the whole function, whether it's a line or any kind of function. If you change the y-intercept, you either move it up or down. So let's say I wanted you to compare y equals x to y equals x minus 2. How would those two graphs compare? Right, this one is 2 spaces below from the parent. Y equals x would look like this. Y equals x minus 2 would just shift down 2 spaces. What stays the same here? The slope. I didn't change the steepness of the line. So y-intercept changes are pretty simple. All it does is takes the whole graph and shift it up or down. Okay, now slope changes are a little bit more complicated because slope does 2 things for us. Slope tells us the direction and how steep something is. So let's go back to our parent function, y equals x. This slope is, what did we say it was? 1. All right, a slope of 1 really isn't called steep or flat. It's right in the middle. So if your slope changes from a 1, in other words, if it gets bigger than a 1 or smaller than a 1, then it's either going to get steeper or flatter. They call it flatter. The other thing is it can also change directions. Y equals x, we say that that line is going up. You read a line like you do a sentence. You read it from left to right. As I move to the right across this line, it's going up. How do you think I could make a line go down? Make, not x a negative, make the slope a negative. Okay, so if I wanted to compare y equals x to y equals negative x, the negative sign does not change the steepness. Because what I did is I went from a slope of 1 to a slope of negative 1. So the steepness is not going to be affected. What's affected? The direction. The new line, I'm going to write it in blue, the y equals negative x, is now going down instead of up. So its steepness is the same. It's just going down instead of up. So the sign, guys, this is important. The sign does not affect steepness at all. The sign affects the direction. And that's important. So this is where you got to pay attention then, because the way it's described mathematically is a little weird when we talk about changing the actual steepness. Okay, y equals x. We're going to change not just the sign, but also the number from a 1 or a negative 1 to something else. Let's try y equals x versus y equals 5x. What do you think is going to happen? It's going to get steeper, absolutely. Okay, y equals x is not considered steep or flat. It's right through the middle. But y equals 5x is going to be rising much faster. It's a much steeper line. Okay, the part you have to write is, let's talk about the steepness. How do you make something steeper then? How do you make a line steeper? You change the slope to something that is bigger than what? 1. Okay, so if your slope, now but wait a minute, let's back up. Let's change the slope to negative 5. Is negative 5 bigger than 1? Okay, negative 5 is not bigger than 1, but does it get steeper? Yes, this will get steep, and it will also go down. This one's going to go down steeply. So we got to be careful how we word this. If your slope gets bigger than 1, you do get steeper, but it's actually the absolute value of your slope. That means you don't look at the sign. Okay, that means the sign does not affect steepness. The absolute value of a negative number is positive. The absolute value of a positive number is positive. So basically that's just a fancy way to say, hey, ignore the sign. Just look at the number. Take the sign off. If the absolute value of m is bigger than 1, that's when you get steeper. So if I told you my slope is negative 5, you got to ignore the negative sign and look at the 5. Is that bigger than 1? That means it's going to get steeper. What does the negative sign do for us? The negative sign just changes the direction. So the sign tells you the direction, the actual number, the absolute value part of just the number, that tells you if it's steep or flat. Okay, how do we make it flat then? Fraction. Very good. Okay, if the absolute value of the slope gets less than 1, no, I'm talking about absolute value. I'm not talking about negatives now. In other words, if it's a fraction or a decimal, less than 1. If it's a fraction or a decimal that's less than 1, that's when your line gets flatter. Okay, so here's y equals x. Here's an example of one that's going to get flatter than the parent function. Y equals x is my parent. Y equals 1/2 x will not be as steep. It's rising slower. That would look something like this. So fractions make you flatter. Fractions make you flatter. If it's a fraction that's less than 1. And the closer and closer you get to a slope of 0, guess what's happening to your line? If it is 0, it's completely flat. Lines that are completely flat have slopes of 0. Alright, now, let's put all this information together in one question. Here's my parent function, y equals x. I want you to picture in your head what y equals negative 2x would look like. What's it going to look like? Is it going up or down? Down. Why do I know it's going down? Because it's negative. Is it steep or flat? It's on the steep side. What's the y-intercept? It's still 0. I didn't change the y-intercept. I changed the direction and the steepness. So it'll be steeper than y equals x, and it'll also be going down. What if I had y equals negative 2x plus 3? What if I have y equals negative 2x plus 3? Then it would just move up 3 spaces. The y-intercept would go from a 0 to a 3. Alright, what if I had y equals 1/2 x minus 4? That would not be steep. It would be kind of flat. So compared to y equals x, it would be flatter. And it would not start at 0. It would start at negative 4. And it'd be on the kind of flat, not steep. So you can kind of have a picture of the line just by knowing its slope and knowing its y-intercept. And that's pretty much it. Tomorrow we'll talk about quadratic transformations, but you need to know that slope affects steepness and what else? Well, that's what steepness means. Steepness and direction. Okay, and what does y-intercept changes do? That shifts the whole line up or down. That's all it does. It does not affect the steepness. It would take the whole line and either move it up or down. And that's pretty much the two linear transformations that you need to be familiar with. Alright, we are going to review domain and range. Tomorrow you have a quiz on domain and range. Hold on to your homework for a minute. Let's look at the warm-up. Okay, so these 5 problems, you can expect to see 5 similar to it tomorrow. I'm going to give you a couple of minutes. Get busy. I'm going to pause. Alright, let's do these together, shall we? Alright, domain is x values, right? So let's look at this number 1, the line segment. For domain on a picture, first of all, there's millions of x values on this line segment. Do you agree with that? I cannot list them all. So I've got to tell what the highest x value is on this picture and the lowest. That's at the left and right edge of the picture. That's this point and this point. This point is at negative 4, positive 1. The point furthest to the right is at positive 5, positive 1. So what's the lowest x value I will ever see? Negative 4. What's the highest? 5. And all of the other x's are somewhere in between. So for domain, I would write the smallest one first, which is negative 4. The biggest one is 5. All the other x's are somewhere in between. And if I start with the smallest, I always use less than symbols. Now, one of them was colored in. The 5 was colored in, so I must always put that extra little equal sign. That's domain. We don't put the line for negative 4 because the negative 4 had an open circle. Now let's talk about range of that guy. Range is the top and the bottom, but there's really not a top and a bottom. There's just points. Anywhere I fall on this line, the nice thing about all these points is they have the same y value. What's the y value of this point right here? 1. I'm talking about the y value. What's the y value of this point way back here? 1. What's the y value of this point? 1. So what are all the y values? 1. So how do I write range? Y equals 1. Yes. Alright, now the vertical lines are a little bit different. It's kind of the same situation except for reverse. For the domain, I want to look at all the x values. I want to look at the left and the right. There's really not a left and a right. There's just points. But all these points have the same x value. What are all the x values on that little line segment? So how would I write the domain? X equals negative 3. Anywhere I fall on that line, the x values are going to be negative 3. Now range, however, does have a top and a bottom. There is a top point and there is a bottom point. So the highest y value is negative 2. The highest y value is right here at negative 2. What's the lowest y value? Negative 6. Now, I usually write the lowest one first, which is negative 6. The highest one is negative 2, and all the other y values are somewhere in between. And they're both colored in, so I'm going to use less than or equal to signs. So that's how you deal with straight up and down or straight horizontal lines. Are you with me? All right, number 3. Number 3, domain is the left and right edge. Now this one's a little bit tricky. The left, there is a left edge, there is a left point. This point is at negative 2, positive 4. However, when I look to the right, what's happening to the right? Yeah, it's the x values are going on forever. The y values are not going on forever, but the x values are. So what's my lowest x value? This is my lowest x value. Do I have a highest x value? It's not all real numbers. The domain here never goes below negative 2. In other words, negative 2 is the smallest one, so all of the other x's have to be bigger. The x values are getting bigger. If you move to the right, your x numbers get bigger when you go to the right. So this domain is x is greater than negative 2. Did it ever equal negative 2? No. Now, what if it was doing this business? Then the x values would be less than negative 2. In that case, the x's go smaller as you move to the left. That's supposed to be straight. All right, now range. Range is a little bit different. The range here is not going on forever in either direction. It has a highest and it has millions of lowists. What's the highest y value? 4. What's the lowest y value? Negative 3. Anywhere I fall on this line segment, it's got a y value of negative 3. So for the range, my lowest is negative 3, my highest is 4, all of the other y's are somewhere in between there. Which one would I put the extra little equal sign on? The negative 3 would, because I am colored in at negative 3 in millions of places, but I was never colored in at the 4. That's my range. All right, number 4 was yesterday's lesson. This one has an asymptote. It's got an invisible line that it's getting close to but will never, ever, ever touch. Domain for this problem should be easy. Look to the left and look to the right. Oops. To the right, I see all real numbers. It never ends to the left or right. Range is not all real numbers. It has a lowest y value. This thing will never go below what? It'll never go below this asymptote. It's never going to get lower than negative 5. All of the other y values are above it. So what does that mean about the range? Y is greater than negative 5. Above means greater than. What if it had been written like this? Then all the y's would be less than negative 5. If it was the red one. All right, what's the domain of this quadratic function, this parabola? All real numbers. I see an arrow on the left and the right. Range is not all real numbers, guys. Range depends on the vertex. This goes up forever, but it does not go down forever. It stops right there. What's the lowest y value I'm ever going to have? Negative 4. And all of these y values are above it, which means greater than it. So the range would be y is greater than or equal to negative 4. Even though I didn't put a giant dot there for you, it's definitely colored in at negative 4. Because it's going through negative 4. If it wasn't going through negative 4, we'd have to put an open circle there to show there's a break in the graph. Alright, some of you better be watching the video. This is on your, there's 2 videos, and this is on your quiz tomorrow. Alright, say goodbye. fourth period.